Alright guys, so as a review, before we get back into quadratic formula, I do want to remind you how to simplify radicals. Anytime you have a number in the radical in your quadratic formula and it does not end up being a perfect square, you do need to simplify that radical. Now sometimes you can't simplify them. So if you had something like root 19 or root 30 that can't be simplified, then you just leave it. But if you can simplify, you need to do so. So here's an example one of root 48. And literally we're just going to do a prime factorization. As long as that number is even, I'm going to keep dividing by 2. So 2 goes into 48 24 times, 2 goes into 24 12 times, 2 goes into 12 6 times, and 2 goes into 6 3 times. So I have 2 pairs of 2's. Any number that pairs up goes on the outside, and when you have multiple pairs, you multiply them. So it's 2 times 2 is 4. And any prime number that doesn't pair up goes underneath the radical. Hence I have 3 here, so it's 4 radical 3. Here's a couple more examples down below. We divide 90 by 2, we get 45. 3 into 45 is 15. 3 into 15 is 5, so I have a pair of 3's, that goes on the outside. And my 2 and my 5 are unpaired prime numbers, so that goes under the radical. Anytime you have more than one of anything, you multiply. So 2 times 5 is 10, and we end up at 3 root 10 there. Root 120, 2 goes into 120 60 times, 2 goes into 60 30 times, 2 goes into 30 15 times, and 3 goes into 15 5 times. So the 2, 3, and 5 are unpaired. They all get multiplied and go into the radical, and my one pair of 2's goes on the outside. Root 63, same deal. 2 doesn't go into 63, but 3 does. It goes in 21 times, and 3 goes in 21 7 times. So a pair of 3's goes on the outside, and the root 7, because the 7 doesn't pair up, goes on the inside. And that's how you break down a radical using prime factorization. Now, sometimes the number under the radical can be a negative. A lot of times people get confused by that, but really a negative under the radical only means that you're going to have an I. So if you look at something like the square root of negative 16, if it were the square root of 16, the answer would be 4. Since it's the square root of negative 16, the answer is just 4i. The square root of negative 49, the answer is just 7i. So ultimately, with these two right here, you're doing the same thing as you would if the number was positive, with the exception of you put an I next to it. And that's it. Now, when they're not perfect squares, you break them down as if they were positive, and then we just put the I on the outside. So the square root of negative 18 is 2 9, and the 9 breaks down to 3 and 3. So my pair of 3's goes on the outside. My 2 goes on the inside. The only difference is instead of being 3 root 2, it's 3i root 2. Here, 2i root 10. And here, 5i root 6. Because you have a pair of 5's, and the 2 and 3 are left over. Here we have the pair of 2's and the 2 and 5 left over. But the key here is we're still breaking it down the same way we've learned previously. We just put an I on the outside. And now, what does that mean for quadratic formula? Well, here's the examples of what it should look like. We still have our A, B, and C. We're still plugging our numbers in. But when we plug the numbers in, we get a negative 28 underneath our radical. And that simplifies to, instead of 2 root 7, a 2i root 7. We take this 2 below and we divide both terms by it. Negative 1 plus or minus, the 2's here cancel, we get I root 7. Same thing down here. My A is 2, my B is 3, my C is 10. When you plug the numbers in, you get negative 71 underneath here. And I probably should have wrote a step here with the negative 71 first. But 71 can't simplify, but you still take an I out. You never leave a negative under a radical. So the correct answer here is just going to be negative 3 plus or minus I root 71 divided by 4. And that is your notes, or me going over your notes for your homework for next class. Hope this helps.